process. Okay, so guys, remember this is a formula to cover. Even by just one formula, you can cram, you can understand all acidosis alkalosis concept. So formula is pH is directly proportional with bicarbonate and inversely relation with carbon dioxide. And pH range is from 7.35 to 7.45. We can take the average 7.40 plus minus it is 0.05. Okay, remember just 7.40. And then for carbon dioxide, remember it is from 35 to 45. You can take the average from 40 plus minus 5. And then for bicarbonate, it is from 22 to 26. You can take the average 22 plus minus, you can take 2. Or it can be 22, 28. So these are the ranges. Okay. So you don't have to cram these values because in the labs the ratios will be given, but I would recommend you to cram them because when you open the labs on the UWord and the exam, it will take time. So it's so easy to cram them. I have just simplified them. Okay, with these, okay, we can see 7.40 plus minus 0.05. And in this case, it is 40 plus minus 5. In this case, it's 22 plus minus 5. Okay, in this way, it is simplified. Okay, then remember, I'm just repeating that formula in two ways. Okay, so pHs have direct relation with bicarbonate. And remember, bicarbonate, it is a metabolic component. Okay, when bicarbonate will increase, pH will be increased. When the bicarbonate is decreased, pH will be decreased. Okay, so that is easy way to cram that. So there is direct relationship. When one is increasing, other will increase. When one is decreasing, other will decrease. And that is your metabolic component. Other formula is pH is, you can see they have inverse relationship with the carbon dioxide. So you can clearly see there is inverse relationship. If carbon dioxide level will be raised, pH will be decreased, and vice versa. If carbon dioxide is decreased, pH will be raised. Okay, that's all. And guys, remember, if pH is decreased, it is less than 7.35. Okay, that will be your acidosis. It means pH at 7 pH is like neutral. If it is decreased, it will be acidotic pH. But if it is more than 7.45, that will be alkalosis. Okay, so that's all. Okay, so whenever you are having the value of pH, then bicarbonate and carbon dioxide, okay, first of all, okay, remember 3 points. First, you will see the pH. Okay, so let me summarize you another page. Okay, so there are 3 important points. First is the pH. Okay, if it is less than 7.35, that is acidemia. More than 7.45, that is alkalosis. Acidemia, acidosis, alkalosis. Done. First, you have decided is it acidosis, alkalosis. Then see that pH change is either due to bicarbonate or due to carbon dioxide. See, either that pH change is due to bicarbonate or carbon dioxide. We have to decide. And third one, you will see compensation. Okay, for example, if bicarbonate is decreased, that compensation will be done by, so suppose that is your metabolic component. Okay, so its compensation is done by carbon dioxide. So what you will do? Hyperventilation. Okay, so to compensate that your lower level, you have to lower your carbon dioxide level. Okay, because when bicarbonate decrease, pH Okay, let me change color. Okay, so when bicarbonate is decreased, pH will decrease. Okay, so you have to increase the pH. So to increase the pH, you have to decrease your carbonic side, because when you decrease the carbonic side, pH will be toward normal. So that's the way. Yeah, in layman language, okay, in layman term, okay, if nominator is decreased, to balance that, we have to decrease the denominator too, because then both will be cancelled out. So that is a mathematical way. Okay, so let's start with the example. Okay, so here is the example of that. For example, the pH is, a formula is given, pH is like that, 7.28, bicarbonate level. Okay, to bicarbonate level that are given, that are 18. Okay, and then you can clearly see that carbon dioxide level is 35. So again apply the formula, pH, bicarbonate and carbon dioxide. pH is 7.28, it means that is acidotic, pH is acidotic. Then apply the, that is bicarbonate, and that is carbon dioxide. Okay, so the guys focus this point because that's important. So that acidemia is either due to bicarbonate, I am putting question mark, either due to carbon dioxide level. So there are 2 points. Either it can be, you can say metabolic acidosis, or it can be, you can have respiratory. Okay. So next ask the question. Okay. If acidemia is due to bicarbonate, bicarbonate should be decreased. So should be decreased. That is the case. Bicarbonate is decreased normal level from 22 to 26. Okay. Then if that acidemia is due to carbon dioxide level, okay, because if the pH should be decreased, okay, your carbon dioxide level should be increased. It should be more than 45 to cause that. So by in this way, then you have interpret that as acidemia, you have interpreted as acidemia or alkalosis, then ask either it is due to bicarbonate, or it is due to carbon dioxide level. For acidemia, bicarbonate should be decreased and carbon dioxide level should be increased. Okay, so that is the case.